Welcome to Study Loop.
Okay, so this is problem 24.77. In this problem, we have a monochromatic light of wavelength 650 nanometers, and that is going through two slits that are 0.66 millimeters apart. So D is 0.66, and we're observing the interference pattern on a screen that is 2.4 meters away from the two slits. Okay. And the question is asking actually if we have another source, okay, and we observed the second order maxima of this other source, and we found it's actually closer to the center by 1.23 millimeters than the second order of the first source. So what should be the wavelength of this source, okay, of the new source? So actually, to solve this, I will first try get the position of the second order coming from the wavelength that we know. So we know the condition for constructive interference and bright fringes from two slits is just d sine theta is equal to m lambda. And in our case, m is 2 because we're looking for the second order. And sine theta, as always, we can substitute for it to be y2 over r. So if we substitute back here, we'll have d y2 for r equal to 2 lambda, and hence y2 is just 2 lambda r over d, which is 2 times 650 times 10 power minus 7 times r, which is 2.4 over d, which is 0.66 times 10 power minus 3. And this will give us 0.004, sorry, 473 meters, which is 4.73 millimeters. Okay, so this is y2. Now we know for the second source, actually the second order was 1.23 closer. So we can say actually y2 prime, which is for the new source, is just this distance that we already got, 4.73 minus 1.23. Okay, so it's 4.73 minus 1.23, which is 3.5 millimeters. And now again the condition is d sine theta is equal to m lambda, and now sine theta is y2 prime over r, and m is 2 again because this is the second order, and we're looking for lambda, so we can get lambda on one side. It will be d over m, which is 2 times sine theta, which is y2 prime over r. And if we substitute back with all the numbers that we have already, so we know y2 prime, we know r and d from the previous question, we'll find out that lambda is actually 4.81, I'm sorry, 81 times 10 power minus 7 meters. And this will be the wavelength of the second source.